Hello everybody, my name is Krishna.Kishore and welcome back to my channel. Hope you are learning every day to keep yourself up in the market. So far in the series of Docker, we have discussed the introduction about the Docker, why, how and when Docker, the drawbacks of virtualization and how it has overcome Docker, the architectural diagram of Docker, the various components in it, how those components talk to each other to achieve Dockerization. We have also discussed about the basic and advanced commands which we use on the daily basis. We have discussed how to data manage in Docker through the volume and bind mount. Today we're going to discuss about the networking concept in Docker. So this is going to be a very interesting session. So please ensure you watch the video till the end. So let's get started. What is Docker network? It's a virtual private network. It's just a virtual private network wherein we create the Docker network and we attach the network to our containers. Why do we do it? We do it for three major reasons. One is better communication amongst containers and for better isolation in Docker and security. So what is better communication amongst network? Let's say if a container A wanted to talk to container B, usually the container A talks to the container B with container B's IP address. But what if the container B restarts or being replaced by the other container? So the IP address of the container B changes and the communication would break over here. Instead of that, if we create both of these container A and the container B in the same network, the container A can talk to the container B with container B's name, which we in turn call it as a DNS name or the DNS discovery. So we will not be worried about the IP address of the container B, whether it gets changed through the restart during the deployment or being replaced by the other containers. So this is one of the major advantages of using Docker network, and it also helps us in isolation. How? In this case, as the container A and the container B serving two other purposes for the same application, so this application would be residing in one container. So these two containers, for example, only these two containers would work in that network. The traffic will not leave that network and it will not disturb or create the bottleneck with the host machine and with the other external system. So what I mean to say is that the communication between that containers reside only in that network, creating the isolation and no disturbance with the host machine. And then security. As for example, if we are creating a web server and database server, okay, so this database would only be accessed by this web server. That means we don't have to expose the details, the secured details of this database, like database username, password, port, so on and so forth, to the any other system or external systems other than the web server, right? So if we do that, if we just expose the details of this database only to the web server, it would be more secure, right? So the web server can talk to the database server with the database server name, and as we are exposing the details, the confidential details of this database only to the web server, we are ensuring more security. So these are the major reasons why we want to use Docker network. The question arises is, does it make difference in communication between the external systems to these containers? No. Why? Because this Docker network is only within the premises of Docker. So the external system still will be communicating in the way how it used to be done without the Docker network. Meaning they still have to expose the port of this container to the option -p and do the port mapping with host port and the container port, such that the external system can talk to this container, let's say with localhost and the host port. So what I mean to say is that the communication between the external system and to these containers remains safe, because this concept of the Docker network is only within the Docker premises. Therefore, the punchline over here is that we go with the Docker network for better communication between the containers and to have the isolation in Docker for a given application and to achieve more security for an application amongst its services. We'll see this with one table that will help you understand in a more clear way. And I've also created a documentation for this Docker network, whatever we are talking about it in this video, or more than what we are discussing in this video. So if you see this table, these are the various major scenarios. So we'll see how can we achieve this without Docker network and with Docker network. Okay, so how the communication happen between the containers by name. So by name, it is not possible without the Docker network. It is possible with Docker network. As the communication between the containers by IP happens without the Docker network, yes, it does, but it is difficult and it is not a viable solution. It can also happen with the Docker network, but we don't usually choose to have the communication between the containers by IP. Instead, we go with the name. We knew the reason why do we do it. As I just said, there won't be difference between the external system and the container communication, wherein we still have to expose port of container, expose the port of the container with the host machine, and the external system can talk to this application with this URL, localhost, and the port number. As we just discussed, the isolation and the security is very high and strong with Docker network, and it is very weak over here. Scalability is also high and easy with Docker network and not without Docker network. And now we'll talk about the types of Docker network. So there are, on a very higher level, there are 5 types of Docker network. One is bridge. So this is the default Docker network, meaning whenever we create a container, it is being attached to the bridge network as it is a default Docker network. Containers on the bridge network can communicate with each other directly with the container name, which is what we are talking about over here, and we don't need the port number over here. So just the container name and no port involved. And it is suitable for the application that runs on a single host. The second one is host network. So the containers on the host network uses the host network instead of the container network or other network. That means it is preferable for the high performance based applications. Why? Because the containers are relying on the host network directly over here and there's no other network involved. So it removes the network isolation between the host and the container. Third one is overlay. It enables the communication between the containers running on the different hosts. For example, if we are setting a container A and container B on two separate hosts, okay, then we may choose the OL as a network because it is suitable for the multi-host and distributed network architecture. The fourth one is MAC VLAN. It assigns a MAC address to each container, making it as a physical device on the network. So the containers can communicate with the external network directly. The fifth one is none. So we can also create the containers with no network. So we choose this when we wanted to separate the container or disconnect the container from any given network. So these are the 5 types of the networks what we have in the Docker, and the default network type is bridge. So now we'll see with the real-time example like how can we create Docker network with the various types, and how we can achieve the communication between the network by calling the destination container's name instead of the IP address. So we'll see 2 examples over here. The example 1 is wherein we'll create a container 1 and container 2. We create network and attach these 2 containers over here. We'll log into container 2 and try to ping or reach container 1 with its name, with container 1 name. Okay, and the other example what we'll do is that we will create a web server with Flask and database, okay, and we'll expose the details of this database only to this web server, and this web server can talk to this database with its name. This is exactly what happens in the enterprise applications, wherein they establish a architecture in such a way that the containers can talk to each other with its name, and they, as much as possible, expose the confidential data only to the required service and not to the others. So let's switch to the terminal and see about the example 1. So how to list the network in the Docker is Docker network ls. So these are the default network what I have in my machine. First we'll create a network Docker. So the command is Docker network create and the network name. For example, my appnet. The network has been created. We can see my appnet over here. Now, as we just discussed, we'll create a container 1 and attach this network to it. So let's create a container 1. Docker run. Let's create this container in the detached mode. The name of the container, for example, my Nginx. The network what we created, my appnet, and the image name. Let's take the Nginx slim image. Let's create this container. The container has been created. Now let's create the another container. Let's create the container my Alpine, for example, not in a detached mode. We will log into the container and try to reach the container 1. So my Alpine, and we'll attach the same network to it, and the image what we will use is Postgres slim image for the faster demo. Assets. So we'll assets to this container. we're not able to log into the container somehow. Let's see it. Let's list the containers. So we just have the container 1, not the container 2. Let's see why it happened. Okay, let's remove the sorry, the container already exists, so let's remove the container my alpha. Alright, let's try creating the we did not create this container in the interactive mode. How about interactive mode? Right, so now we are able to log into the container. We are able to access to this container. Now, as we just discussed, we'll try to reach the container my nginx from this container. So let's try to reach it with the ping command. Perfect, right? So we're able to reach this container with its name. Alright, now let's try to reach the container with the IP address as well. See, we can also able to reach the container my nginx with this IP address, but it gets changed when it restarted or being replaced by the other container wherein we don't usually prefer it. So this is about the example 1. Now we'll see about the example 2, wherein we will create a web server application through Flask, and we'll create a Postgres database, and we'll see the communication between the web server and the database with its name. Let's switch to the terminal. Let's come back from this network. Alright, so I have cloned that repo wherein I have all the related files to showcase this demo. So we have the web server in Python, we have the Docker file, the Docker Compose. Through the Docker Compose we are creating the two services, web service and the database. We have the requirement files to install the required plugins. Alright, so I have cloned the repo already and I have these files on my local machine. So now let's quickly see what are all we have over here. So we have the web service, the web server file, the Docker file, and the requirements file, and the Docker Compose file. Alright, so firstly, so this is the web service file wherein we are wherein we are connecting to the database with its credentials, ensuring. So over here we are achieving the security, wherein we are just exposing the details, the confidential details of the database to the web server only. So if you see, this web server Flask is connecting to the DB with the DB name. So over here in the Docker Compose file, we are creating the two services. We are creating web server and the database server. So here in the web server core, the web server is connecting to the database with the database name. Alright, and in the Docker file, I'm just so this is the Docker file wherein I'm just copying the requirements file and copying the source code and running the web server over here. Alright, so we'll just bring up this application and we'll see how the web server can talk to the database server with the database server name. Okay, so I'm already in the folder, so we'll just bring up the application. So we'll run the Docker Compose. In the coming lectures, we'll also discuss why and how the Docker Compose is needed. Alright, so this is the command Docker Compose up and build. So this will consider the Docker Compose file in the current directory. Okay, so the application has come up. The database system is ready to accept the connection and we can launch the application now. I missed to tell you that we should be able to launch the application and access it on the local browser on port number 5000. So let's go back to our and so what is required over here. So how can we ensure the web server is connecting to the database? So if you see the code over here, we are running this query, the Postgres query on the Postgres database. So when we launch this application, if we see this statement on our browser, it proves us that this web server is connecting to the database with the database name. So let's launch the application on the port number 5000. Perfect, fantastic. So we can see this statement over here. That means the web server is able to connect to the database by the database server name. So this is the way how we can achieve the Docker network, ensuring the wonderful benefits in it. Hope you liked the session. So please subscribe the channel and share the knowledge across. Thank you.